Hello there, this is Mr. Frazier, and welcome to Flipping the Classroom Carnegie Style. And we're going to start with or work on Unit 11. Hopefully there's some things you have in front of you. One of them would be the student assignment for 11.1. You can download that from Portal and print it out, or you can just copy what we're doing. You're going to need a piece of paper so that you're able to do some notes as well as practice some practice problems. We're going to be going through a lot of information at a relatively quick pace, and you'll probably need to pause the video at several times, maybe re-watch it, and make sure you get a lot of the information down so that you understand what you're doing in this chapter, or this unit, excuse me. So we start with a few brief reviews. One of them is understanding mathematically what some of the skills that you should remember. One of them is the ability to distribute. Okay. The other one is something I like to refer to as Acme. You know, like those funny little devices that the Roadrunner always buys, or the Coyote, and they always blow up on them. It's Acme explosives. And it's an acronym, which stands for when we add, coefficients change. And we're talking about the use of variables. So, for example, if you did x plus 2x, when we add, our coefficients change. So the coefficient, we all know, is the number in front of the variable. So x plus 2x is equal to 3x. Now that's an easy one to remember. The second one is when we multiply, exponents change. So, for example, when we multiply x and 2x, the exponents increase. So in this case, x times 2x would be 2x squared. Notice, front number didn't change, the exponent did. All right? So when we add, our coefficient changes, and when we multiply, our exponent changes. All right. Next would be some distribution practice. Okay, so I'm going to really quickly show you some warm-up problems, and what I'd like you to do is work on those problems and then check your answers. I'll go ahead and zoom in here so you can see what the problems are. All right, and I'm going to give you a second to pause it. All right, well, welcome back. I'm glad you paused your video, and here are the practice problems, the warm-up problems. We'll go through them real quick. In this problem, we'd go ahead and multiply the 4 times the 3, 4 times the 6, or you could do your order of operations, which would mean you add 3 and 6 first and then multiply, but they really want you to practice distributing. So 3 times 4 is 12, and 4 times 6 is 24. 24 and 12 is 36. All right, so we go down to the next one. It's negative 5 times x, which is negative 5x, negative 5 times 7, which is negative 35, and you are finished. Now notice when they say simplify, that means you add like terms. We could add here. We can't add or subtract here. They're not like terms. All right, next one, again, we distribute, and this time you're going to see we end up with x times negative 2, which is negative 2x, x times negative 9, which is negative 9x, and when we add these, negative 2x minus 9x is negative 11x. We could add these because they are like terms, right? And then we get to our last problem, and our last problem is x times 8, which is 8x, and then x times x. Hopefully remember our rule we just learned, which would be x squared. Now, please remember, when we write this, we want to make sure we always write the biggest exponent first, just like we always want to write our x in front of our b. Remember linear equations, y equals mx plus b? Well, in this one, y equals mx plus b doesn't exist, but we still can write it with the highest exponent first. All right, And notice that this is a quadratic equation, which leads us into our next thing, quadratics. Let's review some stuff we're supposed to know from quadratics. Okay, remember that quadratics have a parent function. And we've talked about these parent functions. And we've said we know what parent functions are. They're the first or the most used basic equation. So when we had a parent function, we had y equals mx plus b. This was a parent function for linear equations. Okay, well, we have a parent function for quadratics. Ax squared plus bx plus c. All right, and remember, we still have f of x or y. Remember the function of x or y, because this is a function. Now, does anybody else remember any of the quadratic rules? When we look at this quadratic function, we should be able to tell a couple of things about it. First of all, we look at the leading coefficient, that a term. Can anybody remember? Let's think about it. If it is positive, what do we know about our graph? Hopefully remember that our graph is going to be correct. It's a quadratic, or excuse me, it's a parabola. And the parabola is going to be going up. Now remember, my parabola is not exactly how it's supposed to be. It's actually going to be keep going up and away. Okay, I made mine a little too straight. But notice, it's going to be going up and away. It should never be straight and then around and then up. Okay? It's going to be continuously moving away from each other. That's what makes it quadratic. So if this term is positive, thus we're going up. If this term is negative, you've got it, then you're going down. Okay? We also knew that this has an absolute what? Can we remember? When we have a positive coefficient, we have an absolute, excuse me, I apologize. We have an absolute minimum, correct? And when we're going down, we have an absolute maximum. And these are the opposite of our signs. So this is positive, so we have to think absolute minimum. Negative, we have to think, correct, absolute maximum. Just like our other function, which was absolute value functions. All right, so that's a quick review from Unit 1. Things that we're supposed to know. That we're going up or we're going down. Okay, we should still be able to find y-intercepts and x-intercepts. Now, here is something that I'm going to let you know. You will have either one x-intercept, you will have two x-intercepts, or you will have no x-intercepts. You have three different types of x-intercepts. Okay? So what we're trying to say is our parabola is either going to go through the x-axis once, which would look like this. Okay, and it touch once. It will touch twice, which means it would look like this. Okay, it's touching in two spots. Or it never touches. And hopefully you understand that that means the parabola itself is either below, going away from the x-axis, or above, going away from the x-axis. Okay? The one that is the most common that we will deal with is this, that it goes through the x-axis twice. All right, which means most of these will have two x-intercepts. All right, so how do we find those x-intercepts? Or what do we do to use those x-intercepts? All right, well, this is where we use our linear solving, and we're going to look at some problems. Okay. We're going to start with the assignment. Hopefully you have it out now. And put it right in front of you. Let me find mine. There we go. And it says up and down and down and up. And as we read this, Hopefully you read it. It says the citizens of Harrington County are wild about their dogs. They have an existing dog park, and they want to build another one for smaller dogs, and one will be for the larger. The plan is to build a rectangular fenced area that will be adjacent to, that means next to, the existing dog park. The sketch is below. Notice they're only adding how many sides to this? They're only adding 3, okay? They're adding this side, and this side to the existing park. All right, so what do? Well, we know how to write that equation. We would say, okay, we're adding W plus L. And how much fencing will we have? We'll have 1,000 feet. All right, so when we add those, we get 2W plus 1, or excuse me, plus L equals 1,000 feet. Now, they want us, the first thing they want us to do is determine the length of the new dog park in terms of W. So that means they want W in the answer, and they're trying to get rid of the letter L. Well, that means this, in essence, becomes our X, and the other one becomes Y. They want the Y by itself. So we go ahead and move some things around. You know that you can take the 2W and move it over. It becomes negative 2W. So you have L equals negative 2W plus 1,000. All right? Now, right here, I'm going to change my L to a Y so that you can see the difference and we don't think that it's the number 1. All right, so you do realize you can have any variables you want, but we're going to go ahead and stick with Y, and then we're going to go ahead and turn that W to an X so that we're used to what we're looking for, X's and Y's. These would help me with my x-intercept, which is an interesting concept. Okay, so we know that y is equal to negative 2x plus 1,000. All right, so we have one of our equations. The next one is write a function for the area. Now, this is where you are required to remember some other things. Area is equal to length times width. It's a rectangle. So in this case, area equals x times y. But the problem we have is that, excuse me, the problem we have is that our equation is in terms of what letter? We said W. All right, so instead of length, we have y times x, correct? And now we're going to substitute. So our area formula is actually negative 2x plus 1,000 times x. Notice I took out the letter y from here and replaced it with this. We call that substitution. All right? So understanding that we're going to substitute. Now, when I go ahead and substitute, now I can go ahead and distribute. So you go ahead and distribute, pause the video, and then start it up again. And see if your answer matches mine. All right, so you should have distributed. You get negative 2x squared plus 1,000x. All right, so tell me, does that have an absolute maximum or minimum? Yes, it has an absolute maximum because The parabola is going what direction? Down. Correct. Our parabola should look like this, because that is a negative coefficient. And because it's a negative coefficient, we have an absolute maximum. Right? So that's what you would write. Oh, we have an absolute maximum because our parabola is going down, because our leading coefficient is negative. Right. Now, everybody sees the two formulas that we started with, right? We started with right here, our area formula. Now this is important because when I do x-intercept and y-intercept, if I put a 0 in for x, you're going to get different types of answers. Okay? And we're going to have how many, hopefully, x-intercepts? We would have 2. Why? Because we're doing area. And area problems, obviously, have a maximum. You're trying to maximize area. So that means your graph should look like that. Okay. So let's move on to question C. Okay, and question C says, determine the x-intercepts of the function. Explain what each means in terms of the problem of the situation. All right, so when we do this, we go ahead and let me move some things around here. All right, so when we do this, we look at our problem and we know that one of our x-intercepts, and let's just look at the area formula because I'm going to show you something here. In the area formula, we had negative 2x plus 1,000. And then we have x. Notice we have two x's, which means we have two answers for x-intercepts. Remember before we said, oh, when we have one, we have, it crosses the x-axis once. Okay? If we didn't have an x in our problem, it doesn't cross the x-axis. All right, so in this case, we're going to cross the x-axis twice. So how do I figure out what my numbers are? Well, I take this problem, put it equal to 0, and I put this problem equal to 0. Notice they look like there's not two problems there. So I take this x, and I put it equal to 0. Well, it says x equals 0, which means if I made this 0, my y would be 0. Okay, which I go ahead and I can add that point to my graph. It would go right there. And you remember finding x-intercepts, you plug a 0 in for x, and why did we use 0? Or we put a 0 in for y, and we find the x-intercept, put a 0 in for x, find the y-intercept. We swap them back and forth. And the reason why we do this is because then it allows us to find those 2 points. So now I do the same for this problem. And it starts negative 2x plus 1,000 equals 0. And I solve for x. Okay. So I get negative 2x equals negative 1,000. Now remember, what am I doing? I'm finding x-intercepts. I'm plugging a 0 in for y, which would be over here, and solving for x. Well, the first one, when I put a 0 in, I get x equals 0. And the second one, when I put 0 in, I have it equal to this. So now I move my 1,000 over, and then I'm going to do what? Divide by negative 2, and you get x equals 500. Okay, so that means I go over here. These are counting by, hopefully you notice 25. So we got 425, 450, 475, 500. Okay, so here are my two x-intercepts. So what should be the area to maximize, or what should be the number that we use to maximize area. All right, now we figured out that if we have two pieces of fencing that are 500, okay, when we look at this and we explain it, if we used 500, we would have two pieces of fence that were 500, which means we'd have none for the width, or none for the length. It'd be 500 and 500, and that's all our 1,000. Okay? And if we choose 0, we have two sides that are uncovered. Now this all goes back to our original picture. If we had 500 and 500, we wouldn't have any fencing left over for this. And if we made this 1,000, we wouldn't have any left over for here. Okay? So that's where we get the 0. There is no area. You got to have a length and a width. And here, if we have a width of 500, then you don't have any for the length, right? Because this is our width. Because remember, everything was in terms of width, right? And over here would be our area. All right? So you have area and width. All right, so how do we find the maximum area? Well, we know it's a quadratic function, okay? And it will be increasing and then decreasing. So how do I find maximum area? Well, let's look at what would happen if we chose all right, so giving you a little bit of time. And let's look at what a parabola does. Now this is a piece of information that we're going to talk about, that you're going to read about later. And you have to understand. Remember, a parabola goes like this, right? Or it goes in the other direction. But the neat thing about the parabola is it will continuously increase from the same middle, meaning a point that's here will be the same distance from a point that's there from that maximum or minimum. They're going to increase at the same amount, which means when I look at my graph, if the smallest width is 0 and the largest width was 500, because if we had two 500s, we would have no length, right? So if these two are the same distance from the center, where does my center have to be? It'd be in the middle of 0 to 500, which would put it right at, who knows, 250. So 250 ends up being my maximum width. Now, how do I know that? I know that because it's in between 0 and 500. In between my x-intercepts are my maximum possibility. All right, so what do? I take that 250 and put it back into the problem. And let's see what we get for our maximum area. All right, so we take 250 and put it in for our x's, and you end up with -2 times 250 plus 1,000 times 250. This would be -500 plus 1,000, which ends up being 500. And 500 times 250 gives us 125,000. So here we are. And 125,000 would be just a little bit more than 120. So it's between 120 and 130. And there is our maximum value. Right in between. Now, when you get into Algebra 2, you start using a graphing calculator. And your graph becomes a lot more accurate. Okay? You find different spots, and as numbers increase, or decrease in this case, it makes a U-shaped curve. All right? So we're just presenting and understanding what are x-intercepts, which direction does the parabola go, and how do I actually do the math, making sure I distribute correctly and making sure I can come up with the correct answers when I plug numbers back in. All right.